Our three new vocab words, going right along with that essential question, are mean absolute deviation, which is the average distance that each number is away from the mean. The variance, which is the square of the standard deviation, and the standard deviation is a number that describes the spread of a data set. When the standard deviation is high, there may be an outlier. When the standard deviation is a smaller number, that means that the data set is not very spread out. The values are pretty close to each other. Why would we want to learn about new statistical methods? Well, there are some careers out there that involve statistics, and if you're someone that likes to work with numbers and likes to calculate with numbers and not really work with people, there are some really good jobs out there that you might want to explore. One of them is called an actuarial scientist, and actuary for short. Actuaries work for insurance companies and they calculate statistics for insurance companies. And so they work with a lot of numbers, a lot of formulas, and it's a very high-paying job. So look into that if you're interested. Another job would be a statistician, which would be majoring in statistics. Statisticians are employed by a lot of different companies. School districts employ people to work with statistics, especially focusing on standardized test scores, like our MCAs. So there are a lot of opportunities out there if you like doing calculations like these. Our first question says, how do you find the mean absolute variation? There are 3 steps, and these steps are really important to write down in your notes because you'll definitely want to follow them step by step while you work on your homework problems. So step 1 is to find the mean for the set of data. So that just means adding up all of the numbers and dividing by how many there are. Step 2 is to figure out the distance that each number in the set is away from the mean. Now remember, distance is always positive, so you're basically asking yourself, how far away is each of these numbers from the mean that I calculated? Then you're going to find the mean of those distances from step 2. The next example hopefully will help you make some sense of this. Okay, so here we go. The prom committee kept count of how many tickets it sold each day during lunch. 12, 22, 47, 51, 33, 37, and 49. So step 1, we just need to find the mean of those numbers. So that means I need to add them all up and divide by how many there are. There are 7 numbers, so I'll be dividing by 7. When I add them up, I get 251. So 251 divided by 7 is 35.85714, and so on. So I'm going to round that to 35.9. Now, step 2, I have to figure out how far away each of my numbers is from that mean. So distance from the mean. The first number was 12, so 12 and 35.9 are 23.9 units away from each other. I found that by subtracting. My next number is 22, so 22 is 13.9 units away. My next number is 47, and when you're subtracting these, I always start by subtracting with the larger number because distance has to be positive. So it doesn't matter if the distance is on the right or on the left. 51 minus 35.9 is 15.1. So now I've done 1, 2, 3, 4 of them, so I'm up to 33. That one is 2.9 units away. 37 is 1.1 unit away. And my last one is 13.1 units away. So, I need to add those all together because on step 3, we average them. So step 3, I have to add them all together and then divide by 7. So when I add those together, I get 81.1. Divide that by 7. And 11.6 is my mean absolute deviation. So the average distance away from the mean for each of my numbers in my data set is 11.6. One more problem just like that. A rescue agency records the number of pets adopted each month over a 6-month period. So step 1, find the mean. So 14, 18, 12, 17, 15, and 20. We add those together and then we're dividing by 6 this time. So 96 divided by 6 gives me a nice number of 16. Step 2, find out the distance that each number is away from that mean, so away from 16. My first number is 14, so it's 2 away. Second number is 18, that's also 2 away. 12 is 4 away. 17 only 1 away. 16 is 1 away, and 20 is 4 away. Step 3 then is to divide, add those up and divide by 6. So 14 divided by 6, 2.3 repeating. That's the average distance away from the mean. So if you compare our first example to this one, our first example we were 11.6 approximately away from the mean, and this one we're only 2.3 repeating, or 2 1/3 away from the mean. So that means that this set of numbers, the numbers are all more closely, they're bound more closely together than on the last one. Okay, now switch it up. We're going to find the variance and standard deviation. We have 5 steps now. So more complicated, yes. The standard deviation, however, is a much more commonly used statistic for people who work with statistics because it describes the spread of your data set. Step 1 is to find the mean. Step 2 is to find the distance each number is from the mean, just like we did. But step 3, we have to square each of those distances before we move on to finding their mean and then taking the square root. So the extra steps are the ones where we're doing step 3 where we square each of the distances, and then step 5 where we take the square root. Okay, step 1. Find the mean. So add up the numbers. This time we've only got 5. When I add them up, I get a nice number, 50 divided by 5 is 10. So our mean is 10. Step 2, the distance each number is from 10. 5 is 5 away. 7 is 3 away.
Wait, why did you
I don't need a plus yet. So 7 is 3 away, 8 is 2 away, 14 is 4 away, and 16 is 6 away. Now on step 3, remember we have to square those before we add them together. So squaring those gives me 25. It's a weird looking 25. Must be having a bad spot on the smartboard. So 25 plus 3 squared is 9, 2 squared is 4, 4 squared is 16, 6 squared is 36. So step 3, I'm adding those up, and step 4, dividing by how many numbers there are. So 5 numbers. So I get 90. So 90 divided by 5 is 18. So that 18, if you flip back to our vocab words, so that 18 is the variance. And then when we take the square root of the variance, so this is our variance, when we take the square root of it, we get our standard deviation. So the square root of 18 is approximately 4.2, so that's our standard deviation. That is a pretty small number, so it's saying that this set of data is not too spread out with a standard deviation of 4.2. One more example. Step 1. I'm assuming that you know how to do this on your calculator by now, so I'm just going to add them all up. So I have 430 divided by 5. So my mean is 86. Distance away from that mean for each of the numbers. 92 minus 86 is 6. 84 is 2 away. 71 is 15 away. 83 is 3 away. And 100 is 14 away. Step 3, square all of those before we add them together. 36, 4, 225, 9, and 196. Add them, and then we will divide by 5 for our step 4. So 470 divided by 5 gives me 94 for my variance. And then if I take the square root of that, the square root of 94 is about 9.7 for my standard deviation. So this set of data is more spread out than our last set. It's more spread out. So these values ranged from 71 to 100. The standard deviation is just a different way of looking at that spread for the data. Typically, if you're within 1 standard deviation of the mean, you're in a pretty good place. When you're further away, like 2 or 3 standard deviations away, that's when we can be alarmed about your test scores. You should be able to write a summary now, talking about our 3 new types of statistics. And here are your homework problems.